Hello and welcome everybody to our first webinar of 2025. We're talking about deploying and scaling AI with hardware. I'm going to be one of your hosts, Nick Hare, a senior developer advocate here at Viam, and I've been here for about a year and a half. And with me,
Hi, I'm Alan Davidson. I'm a senior software engineer on the computer vision team, and I've been here about 2.5 years.
excellent. So as we get started, first to let you all know who have joined us here today, this session is being recorded, and we'll be sharing the recording with everyone who's attending this afterwards. The audience will be muted, and so we'll be using the Q&A part of Zoom and the chats for you to ask your questions. Feel free to ask throughout the presentation, and we'll get to them at the end. More slides and resources will be shared after this session as well. So anything you see today, if you have questions about it, hopefully we'll be able to answer them through these slides or additional links that we'll be sharing. And feel free, again, to introduce yourself. Hopefully you've already been kind of chatting it up while we've been waiting. If not, get started and we'll follow along as we continue the presentation. So first of all, hopefully some of you know what Viam is as you join, but if you don't, that's great. We're going to go over it anyway. So Viam's goal is to make AI and automation and the physical world accessible to more people, to more developers, to more engineers, which is why we consider it the single platform to collect data, to train machine learning models, to deploy them out to all sorts of different types of devices and help you automate different solutions throughout the world. And so this is a single platform that allows you to design solutions, roll out updates, and manage whole fleets of different types of devices out in the world from, let's take a look at some of these, the platform itself first. First we have VM server that runs on a device, and that device can be really anything, right, Alan? So it could be something like your laptop, it could be a Raspberry Pi, which is very common with a lot of our sort of prototypes and test cases and even products out in the real world. It could be something we'll be looking at today, the NVIDIA Jetson, which is a very popular machine learning inferencing platform because it was really lightweight or small compact packaging with really powerful GPUs for the package, all the way up to full-scale servers if you want to deploy that out onto the edge somewhere. And then we have VM's cloud section and that platform that's available for syncing data off of those devices securely from all of our VM servers around the world, allowing you to then train models, allowing you to, again, manage that fleet, analyze the data, and create alerts around it. Kind of sky's the limit. And then all around that allows you to collaborate with more team members, allows you to securely provide products that you can build around this platform. So some examples of where you might see VM out in the world. So maybe some of you caught our UBS demo where we had a robotic arm programmed to pour wine as well as it could. So it's using a combination of technologies we're talking about today, along with some other parts of the platform to pick up a bottle, know how much wine is in it, and then pour a glass sitting on the table. Some other considerations when you're talking about maybe a fleet of devices rather than a single device. We have Canyon Runner, who has been using it to monitor for their virtual captain services for boats. And so this allows you to gather data from all sorts of devices out in the ocean using stuff like a Starlink connection or other sort of satellite internet to give you a bird's eye view of everything happening within a live map. Or even maybe an autonomous mobile robot like Tenabot, which has been used to collect tennis balls out on the court. This can be really handy as you have a bunch of ones just going off and you don't want to be that person going around and picking it up all the time, especially when you have large courts or large facilities that you're managing. And this is using, again, a combination of technology we're talking about today in terms of running AI on devices and providing a useful solution. So as we get into the content today, let's get a gauge of who's with us in the audience and what is your experience with some of the topics we're going to be discussing. So we'll be popping out a poll right now, and we'll be going over, and you'll have two questions to answer. So the first one is, what is your experience deploying machine learning models? Have you ever done it before? You're just looking into it. Have you been training models, maybe something in like a Google Colab, Jupyter Notebook, or even just running it on your local laptop, but you haven't yet deployed it on production. You're still kind of on that, tutorial section of learning about machine learning. Or maybe you've already deployed them to the cloud platform. So maybe you use some of these cloud services already exist out there. Maybe you're running Docker containers or something somewhere in order to deploy them to a public cloud or even private infrastructure. And then maybe you're familiar more with what we're talking about today in terms of deploying them to edge or embedded devices that can, again, like we talked about today, from Raspberry Pis to servers out in like local data centers, or even NVIDIA Jetsons. And so let's see how people are doing with that. And then the second question is going to be, what is your biggest challenge scaling AI to hardware? If you have had some experience in it, maybe you haven't started at all. You're just still figuring it out. That's why you're joining us here today to learn a bit about it. Maybe you're still struggling to find the right hardware. You're still in that, analysis paralysis in terms of finding, the perfect hardware to run the model that you've chosen, or maybe you're still just figuring out like what hardware is available to you. And then maybe you've deployed it, but it's not necessarily meeting expectations in terms of performance. Or maybe you're struggling to continue getting real-time data from those devices to keep improving upon that model. Or maybe it's just too expensive to keep running it the way you have it right now. So give you all a second to answer. I guess while we're waiting on that, Alan, I guess what would you classify as your experience here with machine learning and deploying them?
So I am a little unusual on the computer vision team for having a lot of experience in grad school in the theoretical background of this, but
Mhm.
not much experience actually with the practical hands-on getting it done and deploying it
Got
stuff.
it.
So I feel like I'm somewhere between beginner and intermediate, and if you had asked anyone else on the computer vision team, they're more advanced to most advanced. Nick, what about you?
I've had some experience now deploying them to devices because I've been working with Viam for a year and a half or so. And so putting those out in production can range from me putting them in my house somewhere for some home automation. I've done them for projects here around work, or through things like we've done some other past like build alongs on our YouTube, where we've built like a LaCroix detection service. And so deploying that was actually just running on our laptops, but then we deployed it then to a Raspberry Pi sitting on like the desk next to me. And so starting to get more and more experience in different types of ways of running them, but still always room to learn.
Sure.
1 second. All right, taking a look at the results. Looks like we have quite a few beginners here, and which is great. You're going to learn quite a bit here during this session. A few people who have actually deployed to edge and embedded devices, and a good mix in the middle between intermediate and advanced. So some of you may have experienced, again, deploying them to the cloud, but may not know what it means to deploy them onto maybe hardware that you have physically in your hand, or that can be in the physical world somewhere. And then biggest challenges. Let's take a look here. So, all right, model performance seems to be the biggest problem and challenge. So, trying to make sure that you can optimize correctly, maybe for that specific hardware, maybe for that specific model, even. Trying to work with choosing the right hardware and real time data handling seem to be neck and neck. Or some people, again, the beginners out there who haven't even started, that makes a lot of sense. And we'll cover a lot of that today. And so, again, the subject we're talking about today around AI is like we're talking about mostly a subset of it, as we can consider computer vision. So, I guess, Alan, what would you say computer vision is to you?
So computer vision is about taking data in sort of an image form, whether it's from a live camera feed or stored images or video or something like that, and doing something useful with it. This can be something on the machine learning side of like recognizing where all the cats are, or recognizing the cats from the dogs,
Mhm.
or it could be something more on sort of traditional computer vision processes, like finding all the edges in the image,
Mhm.
or sharpening the edges, or blurring out the parts that you want blurred, or things like that.
Cool. All right. Makes a lot of sense. So, we're trying to take in image data and apply some pattern or some algorithm around it in order to figure out like, oh, this makes sense now to use for raw data. So it's like a sort
Yeah,
of unstructured data we're trying to find some patterns in, right?
sure.
So when we're talking about, again, adding intelligence to cameras or pictures, it doesn't necessarily have to come from a live camera, but it's really helpful if it does come from a live camera, right? So you want to be able to use with any sort of camera feed that you have. And there's a variation amount of like cameras out there in the world if you look at it, right? So like
Yes.
you've seen probably quite a bit through the computer vision
Mhm.
section, but we're talking about things like webcams that we're running on today. We actually have quite a few of them around us right now,
Yep.
as a little behind the scenes there. But we also have things like RTSP cameras, right, that are on a local network. So
Yes.
yeah, and
And
then
you can send them a request over the network to please give me an image, and it will send you a response back with that image over the network.
you'll probably see a lot of those in commercial buildings, at things like festivals and other sort of venues, even, right? That's
Mhm.
usually more popular than trying to run USB cables or Ethernet around everywhere. You still run Ethernet, but you're not having a hard connection to a single computer necessarily, right?
Yes.
Are there any other
Um,
cameras you can think of that we might use?
Getting a bit further afield, there are depth cameras that
Hmm.
give you not just red, green, and blue, but also how far away is the object from the camera itself.
Got it.
And you can do neat things with that about seeing the shapes of the objects that you're looking at.
Excellent. And so around getting cameras, we get our images. We're starting to now collect those images somehow. You want to be able to then train a model using that data, customize that model to maybe focus on a subset of the subjects that the model might be pre-trained on, right? So that's one section that we're not going to dig super deep into how some of those models are trained, but you can then sort of fine tune or transfer that learning across.
You can do that too, yeah.
And then you can then want to have good feedback on like how well is that model doing. So either you're testing it out on a set of test images, right, or you're then deploying that out and then seeing how it does in real life,
Yes.
and hopefully getting some good feedback, and you're able to track those analytics or observe them in some way.
Yep, that sounds exactly right.
Cool. So again, breaking down those patterns, so we can find a way to collect that data. We're going to find the right model for you, allowing you to kind of be flexible. It's not one size fits all, right? You want to be able to kind of experiment here and there, deploying it to those devices that are connected to cameras, or sometimes directly to the camera themselves, depending on what you're working with, and then continuing to go through that life cycle, collecting more data, refining it, making it better for the problem you're trying to solve.
Yeah, there are a lot of pre-trained models out there that are just freely available to use, and they work pretty well.
Mm-hmm.
But if you want to do something very specific, you can certainly adapt them or fine-tune them or collect more data as you go and train it some more afterwards.
Cool. And so one such problem we might be talking about today is lines, right? Like lines exist everywhere.
And these are people waiting in line rather than lines drawn on an
That's
image.
fair, yes. That's a good clarification there. And as we live in New York City, there's quite a few lines around. Lines for coffee shops, lines at entertainment venues, lines kind of for the subway. They're all around. And so how do you get a good idea of how long the line's going to be? Maybe, especially when we're talking about like venues and like at music festivals or sports venues, they're going to be I'm getting up in a break and I want to know like, all right, how long is the line for the bathroom? How long is the line for the concessions? Like I need to go get a snack. So do I just wander around, or maybe can we solve for that by adding a little computer vision and using existing cameras that are already there to monitor securely on that local network how long are the lines around the entire facility, right?
Yes. And you're totally right that the system that we have built can work for sports arenas, it can work for music festivals or the state fair,
Mm-hmm.
But it could also work for the checkout line at the grocery store or the line for the bathroom, let alone at the ticket counter or wherever there are lines. If you want to know how long the line is, we've got a system that can be used for that.
And so the thing we're going over today is generally called queue management, right? Queue being kind of just saying like we have a line somewhere, we have a bunch of people waiting, or even a bunch of cars. Eventually, you could collect that across to say that there's a line for the toll booth or something, and finding that out. So let's take a look at what you've put together for us today.
Sure. So if we switch over to the tab that has the vision or the model that we've built in it. This is part of app.vm.com. You can see this for any machine that you have built. And we've got a handful of components and services, and let's go through all of these. Let's start with the camera component because that's the most straightforward. We just have, let's back up and talk about the hardware that we're running on.
Okay.
We've got an NVIDIA Orin Nano running all of the stuff. So here is that. It is plugged into a pretty standard webcam. And that's all the hardware that we've got. So you can run it on various other things. We talked about running on servers and stuff, but we've got an Orin Nano plugged up to a pretty standard webcam. Having said that, the camera component that we're using here is just a webcam component. We gave it the path to where it is on the file system, and that's all you need for the camera. For the computer vision stuff, we're using something called the Triton server, which is NVIDIA's framework for doing computations on the GPU. And so because we've got an Orin Nano made by NVIDIA, it's got an NVIDIA GPU in it, the Triton server is the right one to use. We're using this TensorFlow 2 efficient, I'm not sure why it's called efficient det D0, but it is. It was trained on the COCO dataset. It's a fairly standard common machine learning model for recognizing objects in an image. You can pick other ones for different models if you've got some special model that you need, or you want to pick a different, more generic model. Any of them should work with this. And down here we've configured that, here's where we put the model. Here's backing up a minute. Sorry, the machine learning systems typically don't know anything about images. They take input tensors and give you back output tensors. And a tensor is just a bunch of data. And so here in the configuration, we're saying that the input tensor is going to be called image, and the output tensors, there's going to be 4 of them called output 0, 1, 2, and 3, and we're going to call those the location score category and the number of detections. And that's sort of all you need to configure a Triton server.
So we're talking about the model. Where is that model stored? Where do we get it from?
Ooh, great questions. So Viam has a model repository, and if you want to share your model with the world, you can upload it there, and it will be a public model that anyone can use. Within your organization within Viam, you can also have private models, and you can upload again to Viam to the private part of your organization. These are only used in your organization. In addition, Viam works offline without connecting to the cloud, and so if you don't have access to the cloud, but you somehow have the model on your machine already, and it's on the hard drive somewhere, you can set your model path to be anything in the file system as well. This $open curly brace really means that we're going to expand this whole packages.mo model etc. Into a location in the file system. It goes to like the .vm directory, to the downloaded models, to the ML models, to something else in there. That's not important. But the model path could be something downloaded from the modular registry, or the ML model registry, or it could just be something local on your file system.
Got it. And we're getting these packages from this selection up here, right?
Yes.
It's just populated for us.
Exactly.
Cool.
So that is the Triton server to actually do the machine learning. But I'd mentioned that it has input tensors and output tensors. And what we really want are images and boxes around the things that it has found in the image. And so that is where the vision service comes into play. This is super simple. It just says, it takes in an image and turns it into a tensor, and then it gets back a tensor and turns it into a bounding box of something in the image.
When you're talking about bounding box, you're talking about literally a square that you kind of draw around where it detects something.
Let's actually take a look at that.
Okay.
And with any luck, there should be 2 persons in the image. Yep, you can see here's one, there's the other.
Right, let's give a little refresh there to give it
yes.
All right. And so right now we have a webcam over here. I can point it back over here.
I bumped the camera when I showed it to you. So you can see that we're detecting 2 persons. If we had cats or dogs or backpacks or something, it can detect other things as well, but we're using it as a person detector. And that's going to be important because the line is full of people. So if we can detect all the people in the line, we know how big the line is.
So this is interesting, though, that we can actually test this live here. We're not trying to wait for maybe some JSON response to come back from some API, or trying to, we can see we're not writing any code to get this started. This is all just running. Now we can see from the web app just how it actually is running, how confident it is. I'm glad it's fairly confident for people. But we can also see no model's 100% accurate, right? That's kind of you don't want to see 100% accurate because it could lead to other things on the line.
Yes.
Okay. Cool. Now we have detections of people. What do we do with that?
Sure. While we're down here at the bottom of the config, I want to have one more pause here. The VM server has some stuff built in, including webcams, including the vision service to turn images into tensors.
Okay.
It does not have everything built in. In particular, it doesn't have the Triton server built in, and so that is a module that you add on to the main VM server. You can get these from our modular registry, which has lots of components and services that you can get. And so down here, you can see that the Triton service that we're using has come from the ML model service Triton Jetpack.
Rolls off the tongue.
Yes,
Right,
of course.
yeah.
If you try to add one of these and it is in a module, it will prompt you to say, this is in a module, do you want to add the module as well? And you just click yes, and it gets added.
Mhm.
So we've got one of those for the Triton server and another one for the Q estimator, which is also not built in. It's a separate module as well. Or excuse me, separate module as well. And then if we go back up to the top, here is the Q sensor itself. And it is, let's see, how do I scroll down in? Well, okay, so we've got this valid regions setting here in the Q sensor, and this is very general, that you can have a bunch of different cameras with a bunch of different bounding boxes within them. This is a very simple one. We're saying use all of camera one and nothing else. But if your camera has like the line for ice cream on the left and the line for hot dogs on the right, you can have two different Q sensors using the one camera, each looking at a different part of the image. Or vice versa, if you've got a very long line and it fills up the left half of camera one and the right half of camera two, you can have two cameras in one Q sensor with bounding boxes as relevant. So we've got this way of looking at what valid regions in each of the cameras should we be looking for. Then comes the question, what are we going to be looking for? And we're going to be looking for people. As you said, we could look for cars in a line for the toll booth or something else, but we're going to be looking at people. You can average over many different samples, but we're going to keep it simple, just do one sample at a time. And what this is all really doing is saying, grab the images from the camera, send it to the vision service who can turn it into a tensor to send to the Triton server who can run the ML model and find people, who can send it back to the vision service to get the bounding boxes, who can send it back to the Q sensor. And then for how long the line is, we've got these count thresholds down here, that if there are at most 0 people, there's no line. If there's at most 1 person, it's a short line. If there's at most 2 people, it's a long line. You can see over here in the documentation an example of another way to configure it, where there's a short wait if there's 2 people, there's a medium wait if there's up to 5 people, a long wait is up to 10 people, a very long wait is up to 1,000 people. You can have arbitrary labels, you can have arbitrary numbers of people, you can have arbitrary categories, any of that works fine.
It's very flexible to various solutions. It's not just targeted as one sort of type of queue, right?
Yes. Our hope is to make it flexible enough to work for any type of queue you're interested in. And so I need to come down here and grab a camera image. Hopefully we can do picture in picture and pop that out, and then come back up here to the Q sensor itself. And we can see that at the moment there's 2 people in line, which we said is a very long line. But if we were to move the camera so that there's only 1 person in line, now it's a short line. And if we move the camera again so that there's no one in line, there's no line.
It's pretty quick.
It's pretty quick. At the same time, I think we've set it to only update once a second, so that you're not wasting all of your CPU looking at it over and over and over as quickly as possible, because in practice, if it updates once a second, that's fast enough.
Makes a lot of sense.
And that is the demo.
Excellent. Thank you for showing that. Taking a look at what we just went over, so we picked out a CV model, which was that efficient at D0, TF Lite, TF2. We deployed it to our camera, which is connected to the NVIDIA Jetson that we have running VM server. And then we're also still collecting data from it by using that sensor. We're also seeing the live feedback from the vision service in terms of like, here's what it's detecting and how confident it is. And we can look at those analytics later on if we want to be able to collect that as data as well and start to see, like, is the confidence dropping over time? Is it going too high? And be able to start refining that and then continue maybe even training that specific model to maybe focus on specific other items besides people, or we're trying to focus on, maybe at a fan stadium, we want to recognize like a specific type of fan versus another type of fan. We can start to customize it that way as well.
You're alluding to the data management system within VM, where you can configure this to either collect data or not, and if you're going to collect it, how much data to collect, how often do you collect it. And you're right that you can take either readings from the sensors or readings from the cameras or anything else you want, and store time series of this so that you can look at it later and maybe train a different model or whatever you want. Yes.
Nice.
And that's all built into the VM platform.
Seems pretty easy. If you want to follow up on your own, you can check out our documentation at docs.vm.com to explore not only some of the computer vision stuff we were talking about today, but all sorts of other capabilities from moving robot arms, moving bases, gathering other different types of sensor data. You could even go
Servos
through
and motors.
servos and motors. Yeah, those are we have. One of my favorites is our little hand waving bot for Zoom, which I think you helped out.
Oh, I built that. Yes.
Which is a lot of fun. We also have our Discord community if you want to join and share what you're trying to build, and we'll help you get there. Or if you have any sort of other questions you want to ask to the public community, you can join that at discord.gg/vm. Or if you want to start building something yourself, you can go through our end-to-end hands-on tutorials at codelabs.vm.com. And of course, you will learn about any other sort of upcoming events like this, or some of our build-alongs, or any places that we're going to be doing some public speaking, or even hosting events at the VM office, and come check out our lab. You can subscribe to the VM newsletter using that QR code there. And before you go, we want to remind you you'll be getting a recording of this session later on, and provide us any feedback in the chat below about how you think we did. This is, again, it's our first one of the year. We'd like to do many more, and we want to improve upon ourselves. So let us know what you'd like to learn next for the next webinar that we do, or any other things that we can improve upon for these events. But thank you so much, Alex, for joining me.
My pleasure. Thank you all for attending.
Yeah, and have a great day.